Okay, so welcome to this video, and in this video we will talk about vector algebra. So in the last video we worked on we did introduction to electromagnetic field theory, and in this video we'll be talking about vector algebra. So now when we say vector algebra, already like from our general maths secondary school, we know that algebra has to do with equations or expressions involving numbers and letters and numbers. So vector algebra, and from what we have here, it sounds a bit funny, but yeah, simple. Vector algebra is the algebra of vectors. Yes, okay, yeah. Well, vector algebra is the algebra of vectors. Okay, but what that means is that it's a set of mathematical rules that allows meaningful and useful operations in electromagnetics. Already we have vector as one very vital quantity in electromagnetics. But not just vectors. In electromagnetics, there are two quantities we will need. Okay, qualities. But there are two. Okay, and that's the vector and the scalar. Already we know vector to be what has magnitude and direction. So since we know for vectors they have both magnitude and direction, they have both magnitude and direction. For scalar, they have only magnitude, no direction. Okay, so let's consider with the vector algebra. So since we know what vector algebra is, and just by the way I just defined vector, and then close to it scalar, so we know what that is. So there are four basic operations in vector algebra, just like as maths and algebra, we have their operations. This vector algebra also have operations here, and one is the vector addition, and then vector scaling, and then vector product and scalar product. These are the four basic operations. And then the last part of this video is the why vectors. Now if you watch the previous video we did the introduction to vector, introduction to electromagnetic field theory, we talked about that the particles, because we said electromagnetic field theory deals with or is the description of how particles interact with electromagnetic forces. Electrically charged particles knows that. So these electrically charged particles, they have magnitude and they have direction, and that's the vector. That is the reason why we have to study vectors. However, there are two features or there are two properties, yeah, that's what I was looking for. Two properties of vectors that makes them really important to electromagnetics, and one of them is the ability or its ability to describe both magnitude and direction. That is, we see that from the definition of vectors. Then the second property is its ability to describe qualities with great economy in notation. Okay, and when we say great economy in notation, we just mean that instead of having, for example, two equations, we can have one equation that places or contains what we are supposed to have in two equations. We'll have them in one. Just like we have components, or we have motion in x direction and in y direction. That's two dimensions. But instead of writing an equation for x, another equation for y, we can just write a single equation and use the unit vector to represent one dimension, and another unit vector to represent another dimension. So when we say great economy in notation, that's what we're talking about. Okay, the ability to represent or will take a lot, like more than one equation. We can just represent them in one equation using vector unit vectors or the components, that's the x and y. You see, unit vector ijk. Okay, so that's that for this video. And in the next video, we'll talk about magnitude of a vector, and we start going into some calculations, like introduction to it. So magnitude of a vector will be in the next video. So in this video, we talked about the definition of vector algebra. That is recording. Thank God it's recording. Okay, so in this video we talked about vector algebra. I would say it is the algebra of vectors, which means a set of mathematical rules that allows meaningful and useful operations in electromagnetics. And then we mentioned the operations which we have here, and then why vectors. Okay, so thanks for watching, and then of course questions in the comment section. Okay, like I said, this is part of a series, the series class recap. Okay, so just part of studies instead of just studying alone. Let me just bring this study to YouTube. Okay, bring it online so I'm studying and like it's seen, can be seen, so you can comment and everything like that. So I'm a student. Yes, I'm a student. I think I've said that like again. Alright, so that's it for this video. Like, click on your like button, subscribe, click on the notification bell so that when I upload a video next, you see it on time, and then you share this video, and yeah, see you in the next video. Thanks for watching. Bye for now.